Okay, so next week in lab we're going to be doing something a little bit different. We'll call it the Great Collision Hackathon, but also known as Lab number 9. I'll be telling you about how this hackathon is going to be working in this short video. First of all, what is a hackathon and why should we be doing one? What these are typically events that take place over several days, sponsored by a number of high-tech companies such as Google, Microsoft, etc. These events usually are centered around a theme, a product that the company would like to have improved in some way, or possibly new software that they'd like to develop, or perhaps improve a product that they already put out. But teams form around trying to hack the product, and really the term hack means getting deep into the product and trying to figure out at its guts how to improve it. But often these events, after a few days, are judged by a review panel, and there's often some sort of prize associated with being the winning team. Why companies do this? Number one, any company would like to see their employees improve a product. And it's quite likely that after your academic career here at MSUM, you'll be working for some type of organization. And to be a valuable employee to that organization, you should always be evaluating what that organization does and making suggestions for improvement. So we're really trying to model good behavior here, normal behavior in an organization. But the benefit to the company is, of course, an improvement of some sort. But also what they see happen in these events is real bonding and teamwork between employees. So these events are typically the types of things that the employees remember for years to come. And there's kind of like a lot of joshing about who won it last year and some of the silly ideas that came out. So it is kind of like a bonding experience, and we do hope that you learn to work better as a team with your peers now, so that it becomes more natural to do so when you're out in the so-called real world. But what your mission is in this event is to work with a team of either 2 or 3 other people. We'll let you choose that. And in the time allotted, create the best possible VPython code that models an elastic collision and inelastic collision. Typically, a hackathon is kicked off with some sort of presentation, and I'll make this really brief. If you want more gory details on these types of collisions, please go check in Chapter 10 in your text. There's a lot more there than I'm going to go through. But what we mean by an elastic collision is you can imagine 2 objects running into each other, and maybe you can imagine a spring in between them. So when they make contact, the spring compresses and holds whatever kinetic energy the 2 objects had, and as it decompresses back again, it gives all that energy back. So elastic gives the idea of a spring, but typically the word elastic involved in the corresponding term collision means conservation of energy as well as conservation of momentum. So we're going to imagine that our 2 objects are in an isolated system, and so the momentum principle with F net being equal to 0 means, hey, conserve that momentum. But in addition, elastic means energy is conserved as well. So most collisions are not elastic, or they're not perfectly elastic. And so almost all collisions are inelastic. What I'm showing here is something called totally inelastic. And totally inelastic means that there's no bounce whatsoever So here they show that mass A smacks into mass B and it sticks just like a piece of chewing gum or Velcro or whatever you want to imagine in there. So what they're depicting down below is totally inelastic, but you can imagine that maybe mass A would bounce off of mass B a little bit, but energy would not be conserved in the system. So really, generally speaking, an inelastic collision is going to lose some of the initial energy in the system to the surroundings after the collision takes place. And there are a number of ways that can happen. One is through stickiness, but you can also have thermal energy losses, sound, deformation. I like that. Energy of deformation means that some of the energy in that mass A went into smushing the two masses together. Anyway, inelastic typically means conservation of momentum happens in the isolated system, but energy leaves in some form or another. Okay, let me talk a little bit about team formation. So you're going to self-identify at one of three levels, either 1, 2, or 3, depending on your comfort level with coding and computation. And down below I show 2 sample teams that could form, but basically we're talking about someone at level 1 working with someone at level 2, or another team model is a level 2 person working with a level 3 person. And basically we want teams of either 3 or 4, so there'll be 2 different levels within your team, and it may be 2 level 1s and 2 level 2s. Could be 1 level 1 and 3 level 2s. I think a more even mix, though, would be the best possible scenario. But each team, when you're in this team, you're going to be responsible for helping your teammates achieve a new level of comfort with coding. So you're going to teach each other. You're going to push each other. If you're comfortable doing something, you're going to step back and let the people who aren't comfortable do that while you go push yourself to do something different. So let me describe the levels real briefly. And basically, when you come in on Tuesday, you'll grab a piece of paper with a color on it. So if you're level 1, you're going to grab red paper and just kind of try to find people either at level 1 or level 2 to work with. But if you're at level 1, basically you're new to any kind of coding whatsoever, any kind of computer code writing. So you really just aren't very comfortable with VPython yet. You look at the syntax, it leaves you confused. You oftentimes can't figure out the basic logic inside of a program. You get confused by variable names. I mean, we could go on and on, but the basic thing is you are not very comfortable in this VPython environment. So in your team, mostly what you'll be responsible for is trying to understand the basic physics that's going on in the simulation. So your level 2 teammates are going to be responsible for putting the code together and then giving it to you to run and document. So you will try to change parameters in the program, see if it behaves the way you expect it to do. You'll write comments in the program. You'll document the program output and include it like in a Word document that's going to go with your report, explaining what the graphs mean and how they demonstrate what type of collision it was. So you'll be expected to be constantly pestering your level 2 colleagues to explain what's going on, making sure that you really do understand what that code is doing, and letting them know if things aren't working right. Okay, if you're a level 2 person, you're basically fairly comfortable with the code, both syntax and logic, in simple programs. But you really would like to push yourself to learn more about VPython and what you can do with it. So maybe you'll try to put other objects into the code, things other than boxes and cylinders and spheres. You may want to learn how to use the mouse clicks or keyboard strokes to control actions within the program. And you may want to experiment with some of the materials that you can embed into your objects. So you may not be aware of this, but you can make blocks that look like wood or brick. You can make glass spheres. You can do all sorts of really interesting things with an attribute known as materials. But in your group, if you're working with level 1 people, you will be getting the code to work and look as creative and realistic as possible. And you will be expected to help your level 1 colleagues get the code running and respond to their requests for making things look different. Okay, level 3. You'll be grabbing green paper, and I should have mentioned level 2, you're obviously going to grab the blue paper. But level 3 is a whole new level of computer guru. So if you identify with level 3, you're quite likely a computer science major, and you may have written codes to do computer games in your past. So if you're working with level 2, and no, we don't want you to work with level 1, but you will be working with level 2 colleagues, and you'll be expected to show them some nice tricks that you've learned along the way. So maybe you can make the code more general, mathematically speaking. Maybe you can make the code more interactive through these mouse clicks. And maybe you found some really nice ways to make realistic scenes or interesting objects. And kind of on the other side, if you're the level 2 person in this group, now you're going to be the one running the code, requesting things of your level 3 colleague, trying to understand what your level 3 colleague is doing, and documenting it along the way. So just quickly, what is your team trying to improve? You'll all start out with the same small code snippet that will be provided on D2L cartwallsmash.py. So you're going to try to improve this code by making it simulate both inelastic and elastic collisions between two carts. Make the scene as creative as you possibly can. Provide documentation for the code, and show some resulting collisions that you got to happen. Eventually, I'll be asking for both the code and a brief report with results in it. But the report should also reflect back and state the contributions from each team member and what you contributed as well as what you learned. And final statement about the timeline. We'll start next week on Tuesday with formation of groups. You'll have 2 days to work together. There'll be a brief week in between where you'll be working on exam 3, and then one last Tuesday before Thanksgiving. But the reports and the codes themselves won't be due until the Monday after Thanksgiving. So there will be a little time to work on these on your own outside of lab.